Have you ever just looked at a classic watch and wondered, how does that thing work? I mean, it's this tiny, intricate machine on your wrist, keeping almost perfect time. But there's no battery, you don't plug it in, there's no electricity at all. It's this purely mechanical marvel. So, how does it do it?
And yeah, that's the big question, isn't it? In our world of circuits and chargers and constant recharging, how is something like this even possible? The answer is, well, it's both brilliantly simple and incredibly complex all at once. The secret isn't some hidden power cell or a tiny solar panel. It's you. It's us. The simple, everyday movement you make, walking, talking with your hands, just living your life. That's the fuel for this incredible device. So let's break down exactly how that works.
Really, the best way to think about an automatic watch is as a tiny, self-contained, self-winding engine. It's a masterpiece of miniaturized engineering, designed to do one thing beautifully: capture your motion and convert it into the steady passage of time.
Okay, it all boils down to a basic physics principle: kinetic energy. Every single time you move your arm, when you're walking, gesturing, even just typing, you're creating motion, and that motion is energy. And an automatic watch is basically a machine purpose-built to harvest it.
So that's the first big challenge for the watch, right? How does it actually harness that kinetic energy? How does it catch this fleeting, random movement and turn it into a usable power source?
It's actually this beautiful three-step dance. A weight inside spins around. That spinning motion turns a series of gears, and those gears wind up a tiny spring, effectively bottling up all that energy for later. Let's look at the actual parts that make this happen.
All right, let's meet the key players. At the center of it all is the rotor. It's this semicircular piece of metal that just swings freely. As you move, gravity and inertia make it spin back and forth. That spinning connects to some very clever reversing gears, which makes sure the watch is winding no matter which way the rotor spins, clockwise or counterclockwise. And all of that work, all that spinning, has one goal: to tighten the mainspring. You can think of the mainspring as the watch's fuel tank, storing all that captured motion as potential energy.
Now this brings us to a huge advantage over older manual watches. With a manual watch, you could actually wind the mainspring too tight and snap it. It was a real problem. But an automatic watch has this fantastic safety feature called a slipping clutch. Once that spring is fully wound, this clutch just, well, it slips. It prevents any damage from overwinding. It's such an ingenious solution.
Okay, so we've captured the energy, we've stored it, the mainspring is wound tight, like a coiled snake just full of potential energy. The next step is to release that power in a controlled, deliberate way to actually make the watch tick.
It's just basic physics, right? That tightly coiled spring wants to uncoil, and as it slowly and very steadily unwinds, it releases a consistent stream of energy. From this point on, that unwinding force is what drives the entire mechanism.
That power flows into something called the gear train. Now, this intricate series of wheels and pinions has two critical jobs. First, it's like a transmission in a car, carrying power from the mainspring to the next part of the system. And second, it actually multiplies the speed of rotation, turning the slow, powerful unwinding of the mainspring into the much faster motion we need for accurate timekeeping.
And now we arrive at what is, for me, the most magical part of this whole thing. This is where that raw power gets tamed and transformed into the precise, rhythmic pulse of time itself.
We all know this sound. You put a mechanical watch to your ear and you hear its soul. But where does that sound actually come from? Well, it comes from the watch's regulatory system, its brain and its heart, working in perfect harmony.
This relationship is everything. The escapement is the brain. It takes that continuous flow of power from the gears and chops it up, releasing it in these tiny, controlled bursts. But what controls the timing of those bursts? That's the heart, the balance wheel. It's this tiny wheel that oscillates back and forth at an incredibly consistent rate, and it tells the escapement exactly when to release each little pulse of energy.
So just how consistent are we talking about? Look at this number. A typical modern automatic watch performs 28,800 vibrations per hour. That's the balance wheel swinging back and forth, regulating time, almost 30,000 times every single hour.
To put that into perspective, what that means is the escapement is releasing energy and that balance wheel is oscillating 8 times every single second. 8 perfect metered beats that form the foundation of the watch's accuracy. That is the tick-tock you hear.
So we've got our regulated energy.
We've got our perfect 8 beats per second rhythm. The final step in this whole journey is to translate that invisible pulse into something we can actually read on the watch face.
And this is the job of the dial train. It's the last set of gears in the chain, and its job is to take the rapid ticking of the escapement and gear it way, way down, converting that high-frequency movement into the slow, familiar, graceful sweep of the second, minute, and hour hands.
So, that's it. That's the entire journey of energy. We generate power from our own motion, transmit it through the gears, regulate it into a precise heartbeat, and finally, display it as time on the dial. It's a completely self-contained, self-powered ecosystem running on nothing but you.
And that kind of brings us to a final thought, doesn't it? In an age where our phones and smartwatches can do a million different things, there's something just incredible about a device that does only one thing, tell time, but does it through hundreds of tiny, perfectly synchronized parts, all powered by the simple act of living. What does that say about our relationship with technology, and maybe even with time itself?